Okay, we will start with the special methods of spirit leveling, or you can call it as direct leveling. So in that we have differential leveling, profile leveling, cross-sectioning, reciprocal leveling, and precise leveling. So before going to the methods, we will study the basic definitions or basic terms which we get during that leveling process. Okay, first one, station. In leveling, a station is that point where the level rod is held, that is a staff. Leveling rod is nothing but a staff is held and not where level is set up. So where you set up the instrument, it is not called as the station. Station is that point whose level you will be calculating, that is where you will hold the staff. A station is the point where you hold the staff. So it is the point whose elevation is to be ascertained, or the point that is to be established at a given elevation. So I will show you one diagram here. See here. So this is a tripod where you have set up the instrument. Okay. Staff is held at 2 points here. One is at the benchmark BM, they have written. Elevation of that point is known, that is 210.852. And one more point where we have held the staff is at B. Okay, here the stations are point A and point B, where I am holding the staff. Okay, where you hold the staff, that point we call it as station. Next, height of instrument. We denote it as HI. For any setup of the leveling instrument, the height of instrument is the elevation of plane of sight, or else we call it as elevation of line of sight with respect to the assumed datum. It does not mean the height of the telescope above the ground where the level stands. Okay. See this figure. Okay. So height of the instrument is the line of sight. Here it is written. The line of sight is the horizontal axis of your telescope. Line of sight, height of instrument is the height of line of sight from the assumed datum. That is with respect to benchmark here, right? So the level of benchmark is 210.852 meters. 210.852 meters. You staff held the staff reading held at the benchmark is 2.324 meters. So elevation of line of sight, that is height of your instrument, will be level of the benchmark plus the staff reading, that is 2.324. So how to record it, we will study it in the next section. First, understand what you mean by height of the instrument. Height of the instrument is the level of line of sight of the instrument with respect to the datum, or with respect to the benchmark, we call it. Okay. So next, back sight. Back sight is the sight taken on a staff held at a point of known elevation to ascertain the amount by which the line of sight is above that point, and thus to obtain the height of instrument. Backside is the sight or the reading taken always on the point whose elevation is known. So in this case, elevation of benchmark is known here. So if you see this diagram, elevation of benchmark is known, that is 210.852. Okay. So once you hold the staff on the benchmark, that reading we call it as backside reading. Backside reading is the reading or the staff reading taken on the point whose elevation is known. Foresight, which we brief it as FS, foresight. Foresight is a sight taken on a staff held at a point of unknown elevation, or the point whose elevation shall be calculated. Foresighting is equivalent to measuring down from the line of sight. If you see here, so once I take the backside reading on the benchmark, okay, next here I am going to the next point B, whose elevation I need to calculate. So once I take the backside reading, I will get the height of instrument with respect to the datum. Using that height of instrument, I will calculate the reduced level of the point whose RL shall be calculated. Okay. Next, turning point, or you can also call it as change point. Turning point, or you can also call it as change point. So once you set up the instrument, whenever you're performing the leveling in larger areas, okay, from single instrument station, you cannot cover all the points. So in that case, what you have to do, you have to shift your instrument. So before shifting the instrument, you have to shift the instrument. Before shifting the instrument, how to take the readings, that I will tell you now. Change point is a point on which both sides are taken, that is back side and foresight are taken. So before changing the point, the reading which you take on the point is written in foresight, and you have to calculate RL of that point. So once you change the point, or once you change the instrument station, you have to take one more reading on the same point, that is again backside. Backside is taken on the same point in other set of the instrument, again to calculate the height of instrument. So once you change the point, what happens, your height of instrument changes. You are shifting the instrument from one point to other point. In that case, your height of instrument changes. So you have to take two readings on the change point. One is before shifting the instrument, that reading we write it in foresight, and after shifting the instrument, you have to take the reading on the same point, that we write it in backside. Next, you have intermediate station. So intermediate station is the point intermediate between two turning points on which only one side is taken to determine the elevation of the station. So intermediate, if before changing the instrument, what all readings you take, those all are called as intermediate site, or you can call it as intermediate station. Okay, how to perform the experiment and how to note down the readings, that we will study it in the next section. Steps in leveling. There are two steps in leveling. One is to find by how much amount the line of sight is above the benchmark. That is nothing but to find the height of instrument. To find by how much amount the line of sight is above the benchmark. And one next step is to ascertain by how much amount the next point is below or above the line of sight. These are the two steps. Now if I take example, okay, I know the level of the benchmark, I need to calculate the level of point B. Now I need to calculate the level of point B. So how will I perform that, I will explain it now. See, the level is set up approximately midway between the benchmark and the point. So not approximately midway, you can also set up the instrument. You have to set up the instrument such that both the points are visible. That is, benchmark is also visible, and the point whose RL you need to calculate, that point also shall be visible. Right? Like that, you have to set up the instrument. Next, after setting the instrument, first reading you have to take on the benchmark, that is your backside. Okay. So elevation of the benchmark is 210.852 meters here. So backside reading I am getting it as 2.324 meters. So using that backside reading, I can calculate the height of instrument. Height of instrument is equal to elevation of your benchmark, that is 210.852 plus 2.324, that is elevation of benchmark plus backside reading. Elevation of benchmark plus backside reading. That works out to be 210.852 plus 2.324. Your height of instrument is 213.176 meters. 213.176 meters. Next, turning the telescope to bring into view the staff held at point B. A foresight reading is taken. So next, after noting down the backside reading on the benchmark, calculate your height of instrument with respect to benchmark. We have got it as 213.176 here. Next, turn your telescope towards the staff held at the point whose RL or reduced level you need to calculate. At point B, I am holding the staff and I am getting the reading as 1.836 here. If you see this figure, staff reading, I am getting it as 1.836. Now, elevation of point B, or you can call it as RL, reduced level of point B, is height of the instrument, that is 213.176 minus 1.836. minus 1.836. What is 1.836 here? It is your foresight reading. 213.176 minus 1.836. If you do, you will arrive at this point B here. So level of point B. So next, elevation or RL or elevation, you can call it as height of the instrument minus foresight. Height of the instrument minus foresight. So you get it as 211.340 meters. So this is how you should calculate the levels of the points with respect to datum or with respect to benchmark. So any doubts in this? Understood? Confirm anyone? So I hope everyone have understood. So we will move to the special methods of labeling now. So first one, we take it as differential labeling. We also call it as fly labeling. So in differential labeling, we will be calculating or we will be finding the RL of the point, okay, using fly labeling method. The operation of labeling to determine the elevation of points at some distance apart is called as differential labeling. That means, okay, if your point whose RL shall be calculated is away from the benchmark, okay, in that case you have to go for differential labeling. So in the example which I have explained, in that example from the instrument station, both benchmark and the point whose RL shall be calculated are visible. But in few cases what happens, the point whose RL you need to calculate will not be visible, right? So in that case, what you have to do, you have to go on performing the leveling until you reach the point whose RL shall be calculated, right? See here, referring to figure 9.32. So point B is at a distance away from A. That is A is your benchmark whose RL they have given it as 240, right? So referring to figure 9.32, A and B are the 2 points. The distance AB has been divided into 3 parts by choosing 2 additional points on which staff readings have been taken. First reading you will take it on the benchmark always. Set up your instrument. Okay, note down the backside reading on the benchmark 2.024. So once you get the backside reading, calculate the height of instrument. Next go for foresight reading, that is on the change point they have taken, turning point TP1 they have written. Foresight reading, you calculate 1.420, calculate the RL of TP1, that you get it as height of instrument minus foresight HI, that is 242.024 minus 1.42. You will get the RL of TP1. Next, after this turning point, I am shifting the instrument. I have shifted the instrument, and after shifting the instrument, take the backside reading on the TP1 only, 1.986. You get it as backside reading as 1.986. Now calculate height of instrument again. That is RL of TP1, that is 240.604 plus backside, that is 1.986. Right. So you have to perform the experiment until you reach the last point, that is B, and you calculate the RL of point B, 241.202. So now we will see how to tabulate these results. We'll see how to tabulate the results.